Have you ever wondered how AI actually learns? I mean, how does a machine that starts as a complete blank slate suddenly begin recognizing faces, translating languages, or even composing music and creating breathtaking art? It's not magic, folks. It's something far more fascinating. Neural networks, the secret sauce behind modern AI thinking. Hey everyone, welcome back to the channel. If you're new here, we're all about breaking down complex tech into simple, understandable ideas. If you love exploring how our world and the digital minds we're building really work, do me a huge favor and smash that like button, and be sure to subscribe so you don't miss our next deep dive into the future. Alright, let's get into it. What exactly is a neural network? To understand it, let's first think about the human brain. It's this incredibly complex organ with billions of neurons firing, sending signals, and forming connections every single second. Now imagine taking that fundamental concept and translating it into lines of computer code. That's essentially a neural network. It's a digital, simplified version of our brain, a series of interconnected layers of neurons that pass information to one another. Think of it like an assembly line. When you feed a neural network data, say a picture of a cat, it goes into the first layer. This layer might just detect basic things like edges and colors. It then passes what it found to the next layer, which might start identifying simple shapes from those edges. That layer passes its findings to the next, which might combine those shapes to recognize things like ears or whiskers. This continues through all the layers. Individually, each layer doesn't know much at all, but when they work together, they can perform miracles of understanding. It's the collective intelligence that matters. But here's where things get truly mind-bending. Neural networks don't just memorize the data they're given. That would be easy, but not very smart. Instead, they learn from their mistakes, which is the key to genuine learning. When you show a network a picture of a cat for the first time and it guesses dog, it doesn't just get a red X and move on. Instead, an incredible process called backpropagation kicks in. Imagine the network's final guess is way off. Backpropagation is like a manager walking back down the assembly line, telling each worker how their specific contribution led to the final mistake. It goes backward through every layer, making tiny adjustments to the connections between the neurons. It might strengthen some connections and weaken others, effectively telling the network, hey, that feature you thought was important for a dog, it's actually more indicative of a cat. It's like a baby learning to walk, falling down, adjusting its balance, and trying again and again until finally walking just clicks into place. This process is repeated millions, sometimes billions of times, with each mistake making the network a tiny bit smarter. Most of this incredible learning process happens in what we call the hidden layers, the parts of the network between the input and the output that we as users never directly see. These layers are where the real magic of abstraction happens. They break down incredibly complex information step by step. When you show a network a human face, for example, the first hidden layer might just detect pixels and edges. The next might piece those edges into noses and eyes. A deeper layer might learn to recognize the arrangement of those features as a face. And an even deeper layer might learn to distinguish between a happy face and a sad face. Through this relentless process of repetition and correction, the machine slowly begins to perceive the world not just as a meaningless jumble of pixels or data points, but as concepts with actual meaning. But there's a crucial catch to all of this. Neural networks are only as smart and as unbiased as the data we train them on. If you want an AI that can accurately identify different types of plants, you need to show it millions of pictures of all kinds of plants, in different lighting, from different angles. The more diverse, high quality, and clean the data, the more refined and accurate its understanding becomes. Conversely, this is also why bias in AI is such a huge problem. If a network is trained on data that is skewed or incomplete, it will learn and amplify those flaws. Garbage in, garbage out. Today, the evolution of neural networks is accelerating at a breathtaking pace. We're moving beyond just pattern recognition. New architectures are emerging that can reason about the information they process, maintain a memory of past interactions, and even generate entirely new creative content. The line between simply understanding data and demonstrating genuine intelligence is becoming blurrier every single day. We're not just teaching machines to see or hear anymore. We're taking the first steps in teaching them how to think. So the next time your phone's camera automatically tags your friends or your favorite streaming service recommends a movie you end up loving, remember what's happening behind the scenes. It isn't magic, it's a vast, intricate web of digital neurons constantly learning, adjusting, and getting a little bit smarter with every tiny mistake it makes, just like we do. Thanks so much for hanging out and exploring this with me today. What part of AI fascinates you the most? Let me know down in the comments. And if you enjoyed this video, please give it a thumbs up and subscribe for more content. It really helps the channel out. Until next time, stay curious.